Hello everyone and thanks for watching Edupedia World videos. I am Manish Agrawal and in today's session of mole concept we'll continue with chemical reactions and we'll go into details about the calculation part of chemical reactions. Okay, let's see the calculation part. See, it's a very simple diagram here. What I am showing you over here, it's a very simple diagram. What I am saying is that even if I know any one of these moles, volume, molecules or atoms or mass, out of these four quantities, even if I have the knowledge or information about any one, let's say volume, then I can calculate all the rest of them. Okay, if I have information about say number of molecules of atoms or number of molecules, if I have information about number of atoms or number of molecules, then I can calculate moles, I can calculate volume, and I can also calculate mass of the reactants and products. Okay, let's see how. Well, we already know how. We have studied all the formulas. How do we calculate number of moles from number of molecules? Well, it's very simple. If you remember, let me write it down again. Number of moles was equal to number of molecules or atoms, that is number of entities divided by Avogadro number, right? If you remember, so once I know number of molecules or atoms, that is number of entities, I simply need to divide them by Avogadro's number, that is 6.022 multiplied with 10 to the power 23, and the answer will give me number of moles, right? So I can calculate number of moles if I have number of molecules, or vice versa. If I have number of moles, I can calculate number of entities. Okay, right? If I have number of moles, I simply multiply them number of moles with Na, that is Avogadro number. What will I get is number of entities. Okay, and once I calculated number of moles using number of molecules, now using number of moles I can calculate mass. Alright, that is the mass of substance taking part in the reaction. How do I calculate that? Well, if you remember another formula, again for number of moles, another formula that we studied, number of moles is equal to given mass divided by atomic mass, gram atomic mass, or gram molecular mass, depending on whether you are talking about moles of molecules or moles of atoms. If you are talking about moles of atoms, then we use gram atomic mass. If you are talking about moles of molecules, then we use gram molecular mass. Most of the time we'll be talking about moles of molecules, so we'll be using gram molecular mass. Okay, so I calculated number of moles from number of molecules using this formula, using the first formula, and once I calculated number of moles, I substituted them here in the second equation. Okay, and from the second equation I can calculate given mass. Okay, given mass will be equal to moles multiplied with gram molecular mass. Okay, given mass will be equal to moles multiplied with gram molecular mass or gram atomic mass. So I can also calculate mass. Okay, and lastly for volume, well, as long as temperature and pressure of the reaction is given, we can also use the data to calculate volume of the substance. Okay, again it is valid only for gaseous substances. Okay, it is valid only for gases. Okay, it is not valid for liquids or solid. Let's say I am talking about a particular reactant. Say I am talking about reactant B. Okay, and I know that reactant B is a gaseous substance. Okay, I don't care about A, C and D right now. Okay, because I only want to calculate volume of B, so I only need to check whether B is gaseous. Well, B is gaseous, and I also need temperature and pressure. Let's say temperature and pressure is maintained at STP, that is standard temperature and pressure. Okay, you might recall from our last session, standard temperature and pressure is nothing but 1 bar pressure and 273 Kelvin temperature. Okay, so let's say the reactant B is gaseous and it is present and the reaction is taking place at STP. So I have already calculated moles and I need to calculate volume. If you remember, at STP, number of moles, okay, at STP, number of moles of a gaseous substance is always equal to given volume divided by 22.4 liter. Okay, so using number of molecules I calculated number of moles, and using number of moles I can calculate volume of P taking part in the reaction. So this is how we make the calculation. Okay, let's say if in the question what I was given was mass instead of molecule, mole or volume, what I was given was mass. So I use this formula. Okay, I use this formula. I substitute mass divided by gram molecular mass to get moles. Then I use moles to calculate number of entities, that is number of molecules, and volume. Okay, for gaseous substance I can also calculate volume. This formula is valid only for STP. At STP I can divide volume by 22.4 liter to come out and calculate to come up with number of moles. If the temperature and pressure is not at STP or NTP, it is at some other value of temperature and pressure, then this denominator will change. Okay, if you remember from our previous sessions from the Avogadro's law, this denominator will change. Instead of 22.4 liter, we'll have something else in the denominator which we need not go into the detail of right now. We'll study that in our topic of chapter of states of matter. Okay, so let's solve some examples now. Okay, we have studied the theory part about calculations using stoichiometric coefficients. Now let's solve some 2-3 examples and see if we can cover the topic completely. Okay. Example 1. Example 1 asks you to calculate moles of carbon which will completely react with 2 moles of oxygen in a combustion reaction. Okay, combustion reaction is nothing but reaction with oxygen. Okay, and upon complete combustion of carbon, the product formed is always carbon dioxide, that is CO2. Alright, upon complete combustion of carbon, the product is always CO2. Upon incomplete combustion, it is carbon monoxide. Okay, if instead of complete combustion the reaction resulted in incomplete combustion, then the product will be carbon monoxide. Okay, just remember this information, it is quite crucial, though we don't have to use it in this question, but just remember it, that if the question didn't give complete combustion or complete reaction, then we cannot assume the product to be carbon dioxide. It might have been carbon monoxide. Alright, so the question tells us that 2 moles of oxygen reacts with carbon. So we have to calculate moles of carbon. Quite a straightforward question actually. Okay, first we need a completely balanced equation. Let's see if the equation is balanced. Number of carbon atoms on the left hand side is 1. Okay, let's see on the right hand side. On the right hand side as well, number of carbon atom is 1. On the left hand side, number of oxygen atom is 1. Stoichiometric coefficient given is 1. 1 into 2, that is 2. So 2 oxygen atoms on the left hand side. On the right hand side, I have again 1 into 2, that is 2 oxygen atoms. So both carbon and oxygen are same on the left and right hand side of the reaction. That is, the equation is completely balanced. So I need not have to balance it. I don't have to balance it. That is, the stoichiometric coefficient given are the correct stoichiometric coefficient, that is 1, 1 and 1. So this even further simplifies our calculation. Okay, now I have been given moles of oxygen. I have been given that 2 moles of oxygen were used in the reaction, and I have to calculate moles of carbon. Let's say I used N1 moles of carbon. Okay, and let's say N3 moles of CO2, that is product, N3 moles of CO2 were formed upon complete reaction. So in the first part of the reaction, in the first part of the question, what I have to calculate is moles of carbon which will react completely, that is, I have to calculate value of N1. So we already know the relation, N1 divided by small a. What is the value of small a here? 1. Okay, stoichiometric coefficient of carbon is 1. So N1 divided by corresponding stoichiometric coefficient, that is 1, is equal to 2 moles. Okay, 2 divided by stoichiometric coefficient of oxygen, again 1. So N1 divided by 1 is equal to 2 divided by 1. So from here I can say N1 is equal to 2. Okay, so moles of carbon which will react completely with 2 moles of oxygen is also 2 mole. Okay, is also 2. So I need to put 2 moles of carbon in my container for complete reaction. Let's come to the next part. The next part of the question says calculate volume of carbon dioxide released at STP. Okay, now it has asked us to calculate volume of this product, volume of CO2 at temperature and pressure of under standard conditions. Okay, so for that we know the relation between volume and moles. Okay, we know the relation between volume and moles. What is that? N3 is equal to V divided by 22.4 liter. At STP the relation is V divided by 22.4 is equal to N3. So I have to calculate V, that is volume. This implies I need to first calculate N3. And how do I calculate N3? Well, I know that this relation is valid also for product side. So N3, N1 divided by 1 is equal to 2 divided by 1 is equal to N3 divided by stoichiometric coefficient of CO2, which is again 1. Okay, so this implies N3 is equal to 2. N3 is also equal to 2. That is 2 mole of CO2 will be released or will be formed in this reaction upon complete combustion. So now I simply substitute N3 as 2. Okay, I simply substitute N3 as 2. So what do I get? Volume is equal to N3 multiplied by 22.4 liter. That is 2 multiplied with 22.4 liter. So this is equal to 44.8 liter. That is at STP 44.8 liter of carbon dioxide will be released upon complete combustion. Okay, so this answers both the parts of our question, the first part and second part. The answer to first part was 2 moles. The answer to second part is 44.8 liter of carbon dioxide. Right. Let's come to example 2. Okay. Now example 2 says we have a reaction KClO3 arrow with a triangle sign. We know the meaning of triangle sign is that it is a heating. Okay, it is a heating or decomposition reaction. So KClO3 upon decomposition gives KCl plus oxygen. Okay, KClO3 is nothing but potassium chlorate. Okay, KClO3 is nothing but potassium chlorate. So potassium chlorate upon decomposition or upon heating gives potassium chloride. KCl is potassium chloride plus oxygen as products. Let's see what the question asks us to calculate. Calculate the mass of potassium chlorate that will release 1 mole of oxygen gas upon complete decomposition. Okay, so this time I have to make calculation for mass and mass of potassium chlorate. Okay, first I have information about product. Okay, look at the thought process for any question. You cannot, especially when the questions become complicated or long, you cannot directly answer the question. Okay, you cannot directly see, okay, this has been asked, so how do I calculate this? No, you cannot do that. Okay, you do not directly have formula for everything. Okay, you have to go step by step. So first let's look at the information that has been given to us. What has been given to me is a chemical reaction. Alright, and now second thing that has been given to me is information about product side. Okay, one of the product, that is oxygen, information about product side. And what I have been asked is information about reactant side. Okay, so right now we only know few formulas, but when you have hundreds of formula, okay, over the 2 years you will cover up hundreds of formula. So you have to decipher which formula you need to use in which question. So here I have information on the product side and I need to calculate information on the reactant side. So how do I relate reactant to product? Okay, we have only studied one relation for that. Okay, what is that? N1 divided by small a, okay, is equal to let's say moles of KCl is N2 and moles of oxygen is N3. Okay, and that of KClO3 potassium chlorate is N1. So N1 divided by small a is equal to N2 divided by small b is equal to N3 divided by small c. So this is the relation that I have between reactants and products. Alright. So now we know the value of N3. Okay, we know the value of N3. That is 1. 1 mole of oxygen has been formed in the reaction. Okay, this is given in the question. So 1 divided by C. Okay, and I have to calculate mass of KClO3, that is potassium chlorate. So I need information on N1. So N1 by A. Okay, forget N2 for now because we don't need it right now in the question. Okay, so forget N2 by B right now. So N1 by A is equal to 1 by C. Okay, so I need to calculate N1. Okay, I need to calculate N1. So for that I need to know A and C. Okay, for that I need to know A and C. So A and C are nothing but stoichiometric coefficient. And what are the stoichiometric coefficient? 1, 1, 1. No. Okay, the stoichiometric coefficients here are not 1, 1 and 1. That is the number value of A, B and C is not 1, 1 and 1. Why? A, B and C represent stoichiometric coefficient in a balanced chemical reaction. And this reaction which has been given to you is not balanced. Okay, let's look at number of atoms of potassium on left hand side. 1. On the right hand side again 1. Number of atoms of chlorine on left 1. On the right hand side 1. But number of atoms of oxygen on the left is 3. While on the right hand side atoms of oxygen are 2. So there is imbalance. Alright, so the reaction is not balanced. So first you need to balance this chemical reaction. Okay, and we already know how to do the balancing. In fact, in a previous session we have balanced this very chemical reaction. Okay, so upon balancing you will find that stoichiometric coefficient will be 2, 2 and 3. Alright, upon balancing you will find that 2, 2 and 3 are the stoichiometric coefficient. Let's see if it is balanced now. Potassium atoms are 2 on the left, on the right again 2. Chlorine atoms are 2 on the left, on the right again 2. Okay, oxygen atoms are 2 multiplied by 3 on the right, on the left. Oxygen atoms are 2 multiplied with 3, that is 6. On the right hand side oxygen atoms are 3 multiplied with 2, again 6. So 6 and 6. Now all the 3 atoms are balanced. So the chemical reaction is balanced. So I know the value of A, B and C. A is equal to 2, B is equal to 2 and C is equal to 3. Okay, so now I can simply substitute the value of A and C here. What do I get? N1 divided by A, that is 2, is equal to 1 divided by C, that is 3. So N1, okay, so N1 is equal to 2 by 3 moles. Alright, so for formation of 1 mole of oxygen I need 2 by 3 moles of potassium chlorate. Okay, for formation of 1 mole of oxygen I need 2 by 3 moles of potassium chlorate. Okay, but the question is not to calculate moles of potassium chlorate. What do we have to calculate? We have to calculate mass of potassium chlorate. Okay, so this brings us to next subsection of the question. What is that? To convert moles to mass. Okay, we had to calculate information about left hand side, and this is the only relation we know between left and right, but that relation gave us moles, and what we need is mass. So we just revised the relation between moles and mass. What is that? Number of moles, that is N1, is equal to mass, given mass, divided by gram molecular mass. Alright, so moles is equal to given mass divided by gram molecular mass. So sorry for that. Okay, so N1 is 2 by 3 is equal to W is the mass of potassium chlorate that we have to calculate, divided by gram molecular mass. what is the gram molecular mass of potassium chloride? Okay, let's look at over here, KClO3. So KClO3, I have to calculate gram molecular mass of KClO3. Okay, I have to calculate gram molecular mass of KClO3. So that is 1 potassium, 1 chlorine and 3 oxygen atoms. So atomic mass of 1 potassium atom is 39. Atomic mass of chlorine is 35.5. Alright, and atomic mass of oxygen is 16. And I have 3 oxygen atoms, so 16 into 3. So this will be gram molecular mass. 39 gram plus 35.5 gram plus 16 into 3, 48 grams. Okay, this is atomic masses. You don't actually have to remember. Okay, pretty much in every examination they give you the atomic masses, especially for elements like say potassium or chlorine, and eventually over the time you will automatically be able to recall them in the questions. Okay, but don't worry, you don't have to sit and mug it up. Alright, because they will be given in your questions. You won't be given gram molecular masses, but you will be given atomic masses, and from that we can calculate gram molecular mass. In this case it will come out to be 122.5 gram. Okay, in this case it will come out to be 122.5 gram. So I simply substitute gram molecular mass over here, 122.5. So 2 by 3 is equal to W divided by 122.3. Alright, so I can get the value of W, that is mass of potassium chloride initially taken in the reaction. This will come out to be around 81.67 gram. Okay, I have directly calculated here, but obviously you need practice, okay, for numerical calculations as well. Okay, don't assume that once you have written all the formulas and substituted all the values, you will always come out with the right answer. Okay, in fact most of the students, pretty much every student makes 2 or 3 silly mistakes in the exam. Alright, and this is an example of silly mistake where you screw up the calculation part. Okay, so don't do that. Right, so you need practice. I have directly written the answer over here. Okay, but you actually need to manually be able to do the calculations. So W is equal to 2 by 3 multiplied with 122.5. It will come out to be around 81-82 grams. So that is the mass of potassium chloride I initially took in the container. Okay, and that mass of potassium chloride will release 1 mole of oxygen, no less, no more. Okay, let's look at one last example. Okay, read this question carefully. How much air by volume, how much air, okay, basically you have to calculate volume of air, is required to burn 60 gram of ethane completely. Assume percentage composition of air to be 79% nitrogen and 21% oxygen by volume. Alright, so first let's see what the question is talking about. Question is talking about burning of ethane. Ethane is a hydrocarbon. Okay, again you will eventually start to understand what ethane, methane, propane, all these names mean. Ethane is a hydrocarbon with molecular formula C2H6. Okay, we are talking about burning of this molecule ethane. So C2H6, burning in air. Right, burning is nothing but reaction with oxygen. Okay, all the other components of air do not actually take part in the reaction. That is what we always assume. Okay, since they are talking about burning, we will assume that only oxygen from air is taking part in the reaction. All the other components, okay, all the other components act as inert here. Inert means they are not taking part in the reaction. So C2H6 plus oxygen. So C2H6, ethane, is a hydrocarbon, and hydrocarbon upon combustion or burning or reaction with oxygen, okay, they are all synonymous. Combustion, burning or reaction with oxygen, all the three terms, three phases are synonymous. So ethane upon combustion always form carbon dioxide Okay, all the hydrocarbons upon combustion always form carbon dioxide and water. Alright, they always form carbon dioxide and water. Okay, you have to remember this. Okay, that is complete combustion. Since nothing is given, in fact they have given it that it reacts completely. Okay, it burns completely. So upon complete burning or complete combustion, carbon dioxide is formed. Upon incomplete burning, instead of CO2, carbon monoxide is formed. Okay, you can assume water is still formed, though it might or might not be true, but water, obviously some amount of water will be formed, but CO2 is not formed. In incomplete combustion, carbon monoxide is formed. Okay, unless you have more oxygen available, the product will be carbon monoxide. Okay, but here the reaction is complete, so CO2. Okay, next part, you have been given 60 gram of ethane. You have been given 60 gram of ethane, and you have to calculate volume of air required for this reaction. Okay, first reaction is with oxygen, not air. Okay, reaction is with oxygen, not air. Okay, so using 60 gram of ethane, I can calculate moles of ethane. Alright, using 60 gram of ethane, I can calculate moles of ethane. Moles of ethane is N is equal to 60 divided by gram molecular mass. What is the gram molecular mass of ethane? Gram molecular mass, ethane is C2H6. Carbon is 12 gram. Atomic mass of carbon is 12. 12 into 2, 24. And atomic mass of hydrogen is 1. 1 into 6, 6. So 24 plus 6 is 30. So 30 divided by gram molecular mass of ethane is, 60 divided by gram molecular mass of ethane is 30. So moles is 2. So I have 2 moles of ethane in my question. So 2 moles of ethane has been given to me. I have to calculate amount of air, but using the reaction I can only calculate amount of oxygen. But from that I can calculate, from amount of oxygen I can calculate amount of air. We'll see how. Okay, first, to calculate amount of oxygen, what do I know? I know the relation, that is stoichiometric law. Okay, what is the law? 2 divided by stoichiometric coefficient is equal to moles of oxygen divided by stoichiometric coefficient of oxygen. Okay, so first we need to calculate stoichiometric coefficient. For calculating stoichiometric coefficient, I need to balance the reaction. Alright, I need to balance the reaction. So how do I balance the reaction? I have 2 carbons on the left hand side. So here I need to put a 2. Okay, so this solves the problem of carbon. I have 6 atoms of hydrogen on the left hand side. Okay, I have 6 atoms of hydrogen on the left hand side. So here I need 6 hydrogen, means 3 into 2, 6. So this also solves the problem for hydrogen. So now oxygen, I have 2 on the left, but on the right I have 2 into 2, 4 and 3. 4 plus 3, 7. I have 7 oxygen on the right, but 2 oxygen on the left. So I need 7 here. Okay, instead of 2 I need 7 oxygen. So 7 divided by 2. Alright, if you remember balancing, this is how we do it. So stoichiometric coefficients are 1, 7 by 2, 2 and 3. Okay, once again, stoichiometric coefficient, you can leave it as 7 by 2 or you can convert it into whole number. Okay, you can treat a chemical reaction as mathematical equation. If you remember our previous session, we can treat chemical reaction as a mathematical equation. So we can multiply both sides with 2. So that will convert 7 by 2 into a whole number. Alright, or you can just leave it at 7 by 2 and make your calculations. So what is to be done now? So moles of ethane, that is, let's say moles is N. So N C2H6 divided by stoichiometric coefficient of ethane is 1 is equal to moles of oxygen NO2 divided by stoichiometric coefficient of oxygen is 7 by 2. Alright, so moles of methane is 2. So 2 multiplied with 7 by 2, 2 multiplied with 7 by 2 is equal to moles of oxygen. So from here I have calculated that moles of oxygen used is equal to 2 multiplied by 7 by 2, that is 7 mole. 7 mole of oxygen is required. Okay, Now I have calculated moles of oxygen. Okay, but I have to calculate volume, and that is of air. So I have to convert moles into air, and for converting moles into air, what we need is temperature and pressure. Alright, but in this question, okay, I have deliberately not given you temperature and pressure, okay, because sometimes this happens that in the exam the temperature and pressure is not given. So what do you do? Okay, either you might have, if it is an objective type of exam, you might have one of the option as incomplete information, so you mark that as the correct answer, incomplete information, or it might be a subjective examination. Okay, and this is all that has been given. So what do? You assume conditions to be at STP or NTP. Alright, there is no other option. Okay, sounds like a lame way to do it, but that is the only way we have. Alright, if nothing is given, no information about temperature and pressure, we have assumed it to be STP or NTP. Okay, because there is no other way. Unless temperature and pressure is given, we cannot convert moles to volume. Alright, so we need this information. So we have assumed condition to be STP or NTP. Once we do that, we can calculate volume. N is equal to V by 22.4. Alright, moles of N is 7, moles of oxygen is 7. Oxygen is a gas, so we can directly use this formula. So V divided by 22.4. So V, that is volume of oxygen used in my reaction, will be, okay, 7 multiplied with 22.4. That will come out to be around 156.8 liter. Alright, that will come out to be around 156.8 liter. For now we can just leave it as 22.4 into 7, because we have to make further calculations. So I have calculated volume of oxygen. This is volume of oxygen, VO2. Alright, 7 is equal to VO2 divided by 22.4. But what do I have to calculate? What I have to calculate is volume of air, not of oxygen. So how do I do that? See, here I have been given another assumption. Assume that percentage composition of air to be 79% nitrogen and 21% oxygen by volume. Okay, so we have studied percentage composition in terms of moles and mass. Okay, similar is the funda. The same funda we can apply here for case of percentage composition by volume. Alright, so percentage composition by volume is 79% nitrogen and 21% oxygen. Okay, 79% nitrogen, 21% oxygen. What does this mean? This means that if I have 100 liter of air, then out of that 100 liter, 79 liter will be nitrogen and only 21 liter will be oxygen. Okay, so if I have 100 liter, only 21 liter is oxygen. Or in other words, how did we calculate percentage compositions? Okay, per volume of oxygen divided by total volume of air. Okay, how will we calculate total volume of air into 100? This is the percentage composition. Alright, if you remember how we calculated percentage composition, for example, percentage composition by mass. So mass of the particular element or particular substance divided by total mass into 100. Similarly, moles of substance divided by total moles into 100 is equal to percentage composition by mole. So here volume of oxygen is 22.4 into 7. Total volume of air, that is what I have to calculate. My final answer is volume of air. Okay, this has been asked in the question. Volume of air required multiplied with 100 is equal to percentage composition of oxygen. What is the percentage composition of oxygen? 21%. Okay, in this air which has been given in the question, percentage composition of oxygen is 21. So right hand side is already given to us. What we have to calculate is volume of air. So I simply cross multiply. Volume of air will be 22.4 multiplied with 7 divided by 21 into 100. Okay, divided with 21 into 100. Okay, it's pretty simple actually. Okay, that's why we did multiply 22.4 and 7 earlier. Now you can simply cancel 7 and 21. Okay, 7 3s is 21. So 22.4 divided by 3. Okay, into 100. So what you will get is around 74.667 liter. Okay, this will be your approximate answer. You can make the calculations by yourself, but what you have to focus here right now is the method of thought process. Okay, how did we approach the question? How did we come up with the formula that we had to use? Alright, how did we come up with the concept that this is the formula I have to use at this stage, that is the formula I'll have to use later on, and so on. Okay, you can make the calculations by yourself. So this is our final answer, the volume of air which is required, okay, which is required for complete combustion of 60 gram of ethane. Okay, so now this was a very important part of your mole concept. Okay, in fact in the next session we'll study specific cases of these same calculations. Okay, the things might get a bit more complicated, so what you need to do is you need to practice such kind of questions before that. Alright, you need to find from your practice book or your NCERT books or any other textbooks similar kind of questions, practice them and come up with right answers. Okay, so it will make your understanding of your next lectures, the next session, a lot more easy. Okay, so until then, see you, and once again thanks for watching Edupedia World videos.